Hey guys, my name is Sean Deaver. I chose to do my Olympic project on the short track speed skating. So, just a little bit of history. Ice skating was invented in Scandinavia, and back then they used bone on the bottom of their skates to get across frozen lakes and rivers. And then they eventually started using wood skates, and then in the 1500s they switched to iron blades. And then it wasn't until 1850 that they started using all steel blades, and that's what they use now today. So short track speed skating was invented in Canada and the United States of America as early as 1905. There wasn't any 400-meter long tracks around, and so they had to do a shorter track, and they did it inside of a hockey rink. And then all throughout the 1900s, it was getting more and more popular, and then it was officially declared a sport in 1967, and then it didn't enter the Olympics until 1992. But meanwhile, there were other countries like Great Britain, Australia, Belgium, France, and Japan that they continued to further develop the sport, even though it hadn't necessarily been declared an official sport of the Olympics. So athletes start in what is called a pack style type of racing, and there can be 4 to 6 competitors at a time. The track itself it's 111 meters long inside of a 60 by 30 meter ice rink. So like I said, back in when it was first introduced, they didn't have a 400 meter track where they could do it, and so they started doing it inside of a hockey rink. And it is actually, if you watch the sport on TV, it looks a lot smaller, but the rink itself is actually the same size as a hockey rink, but the track is obviously a little bit smaller. There are 8 different events. There's the women's 500 meter, 1,000 meter, 1,500 meter, and 3,000 meter relay. And then the men's, there's the 500 meter, 1,000 meter, 1,500 meter, and 5,000 meter relay as well. And from the Pyeongchang 2018 website, they say that the sport requires more technique than power, more agility than durability. And that's because you can't go as hard as you want, because you have to slow down and you have to make sharp turns and you have to be agile. So the main countries that have the most medals is the number one country is South Korea. They have a total of 48 medals in short track speed skating history. And so this breaks down all the gold, silver, and bronze medals of the top competitors. In this year's Olympics, they had, for the men's 500 meter, it was Korea who got the gold. And then this also just kind of breaks it down in just 4 of the 8 events that they do in the Olympics. So my first biomechanical concept is friction. Friction is obviously necessary in order to push off at the beginning of the race. And then as well as when they're making those sharp cuts and sharp turns throughout the race, they need friction to be able to slow themselves down and also to be able to go faster. And they used to have a clap skate that allowed for the blade to be on the ice the entire time, which allows for involvement of the gastrocnemius, all while the blade remains on the ice. But they've since gone back to the heel in place on the skate, which they believe that it doesn't really matter, and so they allow for friction to be always on the ice, but to always push hard and to get a good glide out of their skate. My next topic is center of mass. This is a big one, obviously, because the track itself is pretty short, but then they have a pretty sharp turn. And so when they're going on the long, quote-unquote, long stretch, they're obviously standing upright, so their center of mass is higher off the ground. But when they go around those sharp turns, if they don't lower their center of mass, they'll do like we've seen many times on TV. They'll fly into the barrier, because that their speed that they're going at and the momentum that they have, it pushes them out of line and it'll make them crash into the walls. So they want to have high center of mass when they're skating on the long stretch, and then they want to lower their center of mass when they're going around those sharp turns. And then the last one is velocity. Obviously this is important because you need to go fast to win, but you can't go so fast that you go too fast around the corner and then you crash and you wreck. So they have to conserve energy to be able to get a maximum amount of velocity on that last stretch. But during the race, you obviously want to have a good position, and so you have to find that sweet spot where you can go fast, and then where you can also go slow. And that's my presentation. Thanks for watching.